Okay guys, today we're going to do 5.2, a little bit of 5.3a, and this actually goes a little bit with 3.5. We're going to talk about polynomials, operations with polynomials, adding, subtracting, multiplying, dividing, and then a little bit of function notation stuff. And so far, we've seen in class, anytime we draw an equation of a line or anything like that, we always call it y equals, y equals, y equals, y equals. Well, what happens if there's more than one line on a graph, and I ask you to point to the y equals line? How would you know which one I was talking about if I kept calling everybody y equals? So what they've come up with is called function notation, where they actually give each equation its own name. For example, they could call it f of x, or they could call it g of x, or they could call it h of x. They can call it a specific name or letter, if you want to say. So that way when I ask you to point to f of x, you know what I'm talking about if there's more than one line on a graph. Okay? Called function notation. So when I give you this f of x or g of x, it's the same thing as a y equals. Okay? All right, so here's our first example. If I tell you that f of x is 2x squared plus 3x minus 1, and that g of x is x squared plus 5, part A says what is g of x plus f of x? So what do you think that's asking us to do? It's asking you to take g of x and add it to f of x, right? Well, what is g of x? Well, it's x squared plus 5. And what is f of x? Well, that's 2x squared plus 3x minus 1. And now I want you to do is add them together. We've done problems like this before, right? There's nothing in front of my parentheses that I have to distribute, so I'm just going to bring it down. There's really a positive 1 here, if you want to think of it that way. But when I distribute it, it doesn't change anything. So I still have my 2x squared, I still have my positive 3x, and I still have my minus 1. Now I wouldn't leave my answer like this because there are like terms that I can combine. So if I have a 1x squared and a 2x squared, together that gives me a 3x squared. I have my lonely 3x, and I have this positive 5 with this negative 1, together that gives me a positive 4. So my final answer would be 3x squared plus 3x plus 4. Okay? Function notation, adding and subtracting them. So you do it the same way that we've done before. We're just going to call them specific names now. So look at B. Example number 1B. What do you think it's asking us to do? The same thing, right? Take f of x minus g of x. So this is the same notation as this. F of x minus g of x. Okay? So this time I'm taking f of x, which is 2x squared plus 3x minus 1. And now I'm subtracting g of x, which is x squared plus 5. And if you noticed on both of these problems, I've been putting this stuff in parentheses. And it didn't really matter on part A, but why does it really matter on part B, on this problem? Well, because I have to take this negative here and distribute it to both things inside. That's going to change my problem a little bit. I'm going to have my 2x squared, my 3x, and my negative 1. And now I'm going to have a negative x squared and a negative 5, making sure I distribute the negative to both things in that second parenthesis. Combine like terms, let's get a final answer here. I have a 2x squared and a negative 1x squared. Together that gives me a positive 1x squared. I have a positive 3x by itself, and I have a negative 1 and a negative 5. That gives me a negative 6. So this would be my final answer when I subtract the two functions. Okay? So make sure that you put that negative in front of parentheses and distribute. That's a common mistake there. All right, so that was adding and subtracting. That was operations with functions. What if I gave you this problem? Example number 2 says if h of x is x squared minus 2x plus 1, what is h of 4? Okay. This does not mean take h and multiply everything by 4. What it means is take out the x and plug in a 4 instead. It does not mean multiply everything by 4. It means anywhere in my H equation, wherever I see an x, I'm going to plug in a 4 instead. Like this. So H of 4 means plug in a 4. Now I'm just going to use my order of operations. Please excuse my dear Aunt Sally. And I'm going to do exponents first. So I have my 4 squared, which is 16. I have my negative 2 times 4, which is negative 8, and the plus 1 in the back. What is 16 minus 8? That's 8. What's 8 plus 1 more? 9. And so H of 4 is 9. I'd like you to try some. So here's try it number 1. If f of x is x squared minus 3x plus 7, and g of x is 3x squared minus 7x plus 7, will you do these two? A, find me f minus g, and on part B, will you find me g of negative 1? I'll give you a couple minutes to do those, please. Okay, so making sure I put in my parentheses, I have my f minus g. Making sure I distribute this negative through, that changes this to a positive 3x. That changes this to a positive 7, and that changes this to a negative 7. When I combine my like terms, I got a 4x squared, 4x. Those 7's go away. So is that your final answer? 4x squared plus 4x? Okay. If you haven't done B, let's do B right now. G of negative 1. Remember, that doesn't mean multiply everything by negative 1. What does that mean to do? It means we're going to take that negative 1 and plug it in wherever we see an x. Wait a second. Are we plugging in the negative 1 to f or to g? To g, right? So in my g function, wherever I see an x, I'm going to plug in a negative 1. Order of operations, please excuse my dear Aunt Sally, says exponents first. I need to take this negative 1 and square it first before I multiply it by that negative 3. Negative 1 squared, that's negative 1 times negative 1, gives me a positive 1. Can I take this negative 7 times positive 7? Or negative 7 times negative 1, can I make that a positive 7? I have a negative 3 plus a 7 plus a 7. Uh-oh. Here we go. Plus a 7. Negative 3 plus 7 is 4. What's 4 plus 7? 11? Did you get your g of negative 1 to equal 11? Okay, so we've added, we've subtracted, we've plugged in a number. What if I asked you to do those two? So what is C asking us for? C is asking us to add them together first, right? F plus G, but then do what with that negative 2? Plug it in, right? Let's do it. What was that? F was my x squared minus 3x plus 7. And G was, and we're adding them, negative 3x squared minus 7x plus 7. So if I add those together, will you add those together for me, please, and combine like terms? And then we'll figure out what to do with that negative 2 here in a second. One minus 3 is a negative 2x squared. I've got this negative 3 and this negative 7 together. That makes a negative 10x. And then I've got a 7 and a 7 together. That makes a 14. But that's not my final answer. Remember, there was a negative 2 in here. So now that I have this new function, what am I going to do with that negative 2? Not multiply it, but remember, plug it in wherever I see an x. Will you use your order of operations for me, please? Will you figure out what that equals when you plug in your negative 2? I got 26. Did you? All right. One last one. Let's see if I can trick you. What if I asked you to do this one? So you know what to do if I ask you to find me f of 4, right? If I have you do f of 4, what does that mean you're doing with the 4? Plugging it in, right? And you know what to do if I asked you to do f of negative 2. What are you doing with that negative 2? Plugging it in, right? So now I'm asking you to do f of x minus 2. What do you think I'm doing with that x minus 2 then? Plugging it in. So in my f function, wherever I see an x, I'm going to plug in what? An x minus 2. That means here and here. So taking my f function, wherever I see an x in all the x's, I'm going to plug in an x minus 2 instead. All right, using my order of operations, we've got to do this first. I have an x minus 2 squared, but I cannot just take that little squared and distribute it and say x squared plus 4. It does not mean the same thing. What does it mean I have to do if I have an x minus 2 squared? FOIL it, right? X minus 2 times an x minus 2. So let's FOIL it out. X times x is x squared. X times negative 2x is negative, or x times negative 2 is a negative 2x. Negative 2 times x is a negative 2x, and negative 2 times negative 2 is positive 4. That's me foiling. Is that my final answer? Nope. So now that I've combined my like terms, is that my final answer? X squared minus 4x plus 4? No. Don't I still have all this stuff I need to add to my list of terms? So let's take this negative 3, let's distribute it through. I have a negative 3 times x, a negative 3x. I have a negative 3 times negative 2, that's a positive 6, and don't forget about the plus 7 in the back. Now will you combine like terms and get me a final answer? I got x squared minus 7x plus 17. Good? So you should be able to add and subtract using function notation. You should be able to evaluate, meaning you should be able to plug in a number in function notation. And you should even be able to plug in an expression, like an x minus 2 from the last one. We've got one more quick example to do. Let's look at this last example, number 3. Example number 3 says that the number of U.S. households estimated to pay at least one bill online each month during 2000 and 2006 can be modeled by this equation. So this is the number of people that pay at least one bill online. They give us this equation. It says x equals 0. Let's let x equal 0 for 2000. That means x equals 1 for 2001. So for 2002, what would x equal? 2, and so on, right? It's asking us to find the estimated value for 2005. So what does that mean? X equals 5, right? Because it's 5 years away from the beginning. If 0 is 2000, 1 is 2001, 2 is 2002, 3 is 2003, 4 is 2004, 5 is 2005, x equals 5. So then how would I figure out how many people paid a bill online in 2005 and x equals 5? And I just plug it in, right? So I'm going to find how many people estimated to pay a bill online in 2005 by plugging in a 5. All right, here's where we're going to take out our calculators because I don't want to figure out what 0.808 times 25 is. So if you'll take out your calculator for me, please. If you'll enter this into your calculator and get me a final answer, please. I should be able to still see your setup, though. On your test, this is what I'm looking for. And then your final answer. Five squared, 25 times 0.808 plus 2.625 times 5 plus 0.502. You should get 33.827, blah, 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 blah. If we're talking about people, and in this problem, weren't we talking about millions of people? So how would we say this number in millions? Would we say normally 33.83 million people paid at least one bill online in 2005? Or I guess this would be million households. Okay? So you should be able to kind of apply it to a real world situation by being able to plug in a number and evaluate. Okay? Your homework tonight is your 5.2, 5.3a, 3.5 worksheet. If you'll do that